Welcome to this predicted paper. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by clicking the link. Our website is full of free content to help you with your exams. You can even save your scores with a free account. Enjoy! A bakery tracks the number of loaves of bread sold from Monday to Thursday. This helps them understand which days are busier and plan their stock accordingly. Find the amount of loaves of bread sold on Wednesday. The first thing to do is look at the key, and the key shows us that one of these squares represents 8 loaves of bread. So on Wednesday we have 2 of these squares, so 1 and 2, each representing 8. So 8 plus 8 will be 16. Find the amount of loaves of bread sold on Monday. Looking at the key, we know that the big squares are 8, so that should be easy to find the amounts for the first 5, but here we've got a piece missing on the last one. So we need to work out what each of the little squares is worth. Well, there's 4 little squares and they're worth 8 together, so each of them are going to be worth 2, so 2, 4, 6, 8. So we've got 2 here, 2 here and 2 here. 5 times 8 is 40, plus the 6 at the end will be 46. On Thursday, the number of loaves of bread sold was 32. Show this information on the pictogram. First of all, we need to work out how many squares we'll need. So we do 32 divided by 8, which is 4. And then we need to draw them on. Now try and keep them roughly in line with the ones that are already there. Doesn't have to be perfect, as you can see from mine. It's not perfect, but it's good enough, and that's what we need to be focused on. And then we need to draw our other lines in. And you're not going to lose any marks if it's not absolutely perfect. Just make sure they're roughly lined up with the ones, roughly the correct size, and roughly in the correct positions, but that would be more than good enough to get full marks. Felix suggests redrawing the pictogram using a key with a whole square representing 5 loaves of bread. Explain why this key would not be suitable. Looking at our pictogram, we know that there were 6 loaves of bread sold on Tuesday. Now, if this big square here represented 5 loaves of bread, how would you show that 6 were sold on Tuesday? Well, the first 5 would be easy because it would be a whole square. But then you're left with this awkward amount because the square is split up into 4. It's not split up into 5. So it's going to be really difficult to show that final amount. So what you need to do is just write down that Tuesday shows 6 loaves of bread. This would therefore be very difficult to show because 6 has a remainder 1 when divided by 5. Sarah has surveyed 35 students about the number of books they read in a month. Each student read between 0 and 4 books. The incomplete bar chart shows the number of students who read 0 books, 1 book, 2 books and 4 books. 4 people read 3 books. Complete the bar chart. Always start by checking the y-axis in case there's a weird scale. Here the frequency just goes up in ones. Now a bar chart will always have a space between each of the bars. So we're going to draw our bar going up to 4. Find how many more people read no books than 2 books. Let's start by finding out how many people read no books. So it's this bar here for 0, and it goes up to 9. Now for 2 books, it goes up to 5. So we're just going to do 9, take away 5, which will equal 4. Sarah wants to open a library in the student's school. She thinks that because most students read 4 books a month, then the library will be popular. Explain why Sarah may not be right. Let's start by looking at the bar chart. Now Sarah is right, there are 10 students who read 4 books a month, but let's look at how many didn't read any, and that's 9, or how many read 1, and that's 7. So altogether there are 16 students who read 1 or less books, and that's significantly higher than the 10 that read 4. So our answer will be that more students read 1 or less books a month. A school is considering introducing a new lunch menu. Daniel is going to conduct a survey to gather opinions from everyone in the school. Daniel thinks that he should take a sample rather than a census. Give 2 reasons why Daniel might think this. A census would require Daniel asking everyone, yet with a sample he only needs to ask a few people, so it will be cheaper and it will be quicker. Daniel has decided to use the class registers as a sampling frame. Explain what a sampling frame is. A sampling frame is a list of all the members in the population. Daniel has decided to use the class registers as a sampling frame. State one problem Daniel may have using the class registers as a sampling frame. Try and think of a member of the population that will not be on the class registers. Of course, the staff. So the problem is that the staff will not be included. Give 2 reasons why Daniel should conduct a pilot study. A pilot study is a much smaller scale survey, so he can ask a few people just to check whether the survey has any issues, and also to give an indication of what the results may be. Daniel is writing a plan for the investigation into students' opinions on the new lunch menu. Write down what Daniel should include in the plan and explain why each of the things is appropriate. You should include a sampling method, a question Daniel should ask in the questionnaire, a statistical diagram to show the results of the survey. Let's start by looking at the sampling method. Daniel should use stratified sampling. This will ensure that the sample is representative of the school. Next, let's look at the question Daniel should ask in the questionnaire. Question could be, how satisfied are you with the current school options? Very satisfied, satisfied, neutral, unsatisfied, or very unsatisfied, each with their tick box next to them. The question is clear and unbiased, avoiding leading students to a particular answer. Finally, let's talk about the statistical diagram. A bar chart could be used to display the data. This is because it shows frequencies and allows for visual comparisons. Ryder is studying blue whales and needs to know the average length of a blue whale. Ryder uses the internet to find that the average length of a blue whale is 24 metres. Explain why the statistic collected by Ryder is an example of secondary data. This data is secondary data because it was not collected by Ryder, it was collected by another researcher. State one advantage and one disadvantage of using secondary data. One advantage is that it's cheaper to collect, and one disadvantage is that Ryder can't control the quality of the data. Sophia is an NHS trust manager investigating the working hours of junior doctors. She takes a simple random sample of 12 doctors in a hospital and asks them to report the number of hours they worked last week. The working hours of the 8 people are listed as 36, 41, 39, 70, 40, 38, 42 and 38. Sophia believes that one of the values is an outlier. Describe the meaning of the term simple random sample. A simple random sample is a sampling method where every individual in the population has an equal chance of being selected. Work out the mean. To find the mean, we need to add up all the numbers and then divide by the amount of numbers. We're told that there's 8 people, so we're going to do 344 divided by 8, which will equal 43 hours. Work out the range. The range is the biggest take away the smallest. The biggest number here is 70 and the smallest is 36. 70 take away 36 is 34. Write down the value that is most likely to be an outlier and explain why you think this value is an outlier. Looking at the numbers, all the numbers are roughly 40. We've got 36, we've got 38, 41, 42, but there's one number that is vastly not near 40, and that's 70. So the outlier is 70, and the reason is that it's significantly higher than the other numbers. Sophia removes the outlier. State whether the mean of the remaining 7 values is greater than, is equal to, or is less than the mean of all 8 salaries. Give a reason for your answer. The mean is going to be less because the value that Sophia removed is higher than all the other values, therefore the mean will decrease. After calculating the mean of the 7 values without the outlier, Sophia uses this mean in a report to describe all the doctors in the NHS, describe 2 things that could affect the reliability of her conclusions. Sophia only asked 8 people, and we're only using data from 7, so there's a small sample size which will affect the reliability. Also, Sophia removed the outlier, and that's normally okay, but it could be that removing the outlier may ignore the true variation in working hours. The accurately drawn pie chart shows information about how people in the UK rated their health in 2021. Explain how you can tell that most people viewed themselves as very good health in the UK in 2021 using the pie chart. If we look at the pie chart, very good health is this shade here, so it's this one here, and it definitely has the largest sector, so very good health has the largest sector. The population in the UK in 2021 was estimated to be 67 million. Calculate an estimate for the number of people in the UK in 2021 who rate themselves as having good health. Round your answer to the nearest million. Good health is shown by this shade here, and we just need to get a protractor out and measure the angle of the good health, which is 122 degrees. Next, we need to work out what fraction of the full circle that is. So it's going to be 122 degrees over 360 degrees because there are 360 degrees in a circle. Finally, we need to multiply that by 67 because we know that the population is 67 million. So it's going to be times 67. Now our answer will be whatever million, so we don't need to write 67 million, we can just do 67. And when we do that, we get 22.70555, and to the nearest million, that will be 23 million. Sophie recorded the heights of male and female students in a school. Both groups were measured using the same method. The box plot shows information about the heights for the male students. The table gives information about the heights for the female students. Draw a box plot for the heights for the female students. The female students' heights are given to us in the table, and the least tall was 150. So on our graph here, I'm going to draw a line at 150. Then the lower quartile was 158. And we can see here that each of the little squares is going to be 2. Then the median is 162, so we'll make sure that goes there. Then 172 is going to be there. And then 190 is the most tall. Now we need to join these up properly. So we have our little whiskers here, and then we've got the box here. Make sure I get this right. There we go. Compare the 2 distributions of heights. Give 3 comparisons and interpret one of these comparisons. We're going to start by comparing the medians. Now the medians for the males was 170 and for the females it's 162. So in the comparison we're just going to write the median heights for the male students is greater than the female students. Next we're going to compare the interquartile ranges. So the interquartile range for the males was 178 take away 162, so that's 16, and for the females it's 172 take away 158, so that's 14. So we're going to say that the interquartile range for the height of the male students is greater than the female students. Next we're going to look at the skew. So looking at the male box plot, it looks pretty symmetrical. Now for a previous question we did the box plot for the females, so I'm just going to show that now. And you can see that the skew for the females is positive, because if you look at this gap here and compare it to this gap here, and same with the distance between the median and the upper quartile compared to the distance between the median and the lower quartile, it's definitely a positive skew. So if we go down, then we can say that the skew for the heights of the male students is symmetrical and the skew for the female students is positive. Finally, we're asked to interpret one of the comparisons. I'm going to interpret the median heights being bigger for the male students and say that the male students are on average taller than the female students. Liam gathered data on 11 movies, recording their production budget in millions of dollars and total box office revenue in hundreds of millions of dollars. He represented his findings in the scatter diagram below. One of the 11 movies has a budget of $55 million. For this movie, write down its revenue. If I draw a line up from 55, we can see that this line crosses over one point, this point here. I can then draw a line across to find that the revenue is this 6 here. But what does that 6 represent? The revenue is in hundreds of millions of dollars. So that 6 represents $600 million. Draw a line of best fit on the scatter diagram. When drawing a line of best fit, there's a couple of rules. The first one is the line must go with the data. So if you draw a line down like that, that's not going to be good. And the second one is that there needs to be roughly the same amount of points above and below the line. So if I draw my line of best fit in like this, and what you can do is you can just rest the ruler on top of the page until you're ready to draw a line of best fit. Now, if you haven't got it absolutely perfect, it's a little bit too high or a little bit too low, don't rub out and start again. There's quite a big tolerance for the line of best fit. For instance, on this one, it could probably be a little bit higher. Describe and interpret the type of correlation shown by the scatter diagram. When asked to describe a correlation, you're looking to see whether it's positive, negative, or there's no correlation, and whether it's strong or weak. Looking at R1 here, it's going up, so it's going to be positive. And if you look, all the points are close to a line of best fit that we can draw, so it's going to be strong. Now, when asked to interpret, we need to relate that to the question. So we say, as the budget increases, the revenue increases. A new movie will be releasing soon with a budget of $250 million. Liam is planning on using the line of best fit on the scatter diagram to predict the revenue of the movie. Explain whether or not it is appropriate to use the line of best fit for this prediction. If we draw on our line of best fit to the scatter diagram and have a look at where we think roughly 250 is, I think about there, so $250 million. I mean, you could see that we could use it to predict and then draw a line across and then work out what this number here is. But you can see that the value is vastly outside of the range of the data that we have. So our answer will be that it's not appropriate because this would be extrapolation, which is where you are using your line of best fit outside of the range of the data. Sophia investigates the heights of 210 students in a school. The heights range from 129 centimetres to 203 centimetres. Sophia considers using one of the two possible group frequency tables for the results, Table A or Table B shown below. Give 2 advantages of using grouped data rather than raw data. Group data makes it easier to process large amounts of data, and it can make it easier to compare different groups. Give 1 disadvantage of using grouped data rather than raw data. When you group data, you lose the detail in the data. Sophia feels that Table B gives more detail than Table A about the results. Assess the appropriateness of Sophia's claim. Looking at Table A, there are no frequency for 90 to 120 or 210 to 240. So all the data is sort of squeezed into the 120 to 210 range. But looking at Table B, there are 13 in the first group, 62 in the second, 109, 24, and then 2 in the last one. So the data is more spread out. So in Table A, there are no students in 2 of the groups, so these groups are not needed. In Table B, each group has a smaller class width, showing more detail. So Sophia's claim is justified. Make sure to always write the conclusion. Sophia wants to work out the average height of the 200 students in the school. She decides to use Table B. Calculate the average height of the 200 students in the school, giving your answer to 1 decimal place. To find the mean, we need to add up all the numbers and divide by the amount of numbers. But the problem is we don't know what the actual raw data was. So what we need to do is first of all change all of the heights here to their midpoint, so that to work out the mean we need to first of all add up all the numbers and divide them by the amount of numbers. Now the problem is we don't have any of the raw data here. For instance, we know that there are 13 heights between 120 and 140, but we don't know what they are. So the first thing we need to do is work out the midpoints for each group. So instead of putting them as sort of a big question mark, we could say that all of those ones in the first group were 130, because that's the midpoint of 120 and 140. If you don't know how to find a midpoint, what you can do is you could add the two numbers together, the lower number and the upper number in the group. So 200 plus 220 is 420, and then divide by 2, which is 210. Now, we have assumed that all of the numbers in the first group are 130, but we've got 13 of them, so we need to add up all 13 of those. So we can just multiply the 13 by 130, which will give us 1,690. And we can do this for each of the groups. So now we know each of the groups, what they add up to. We need to find out what the total add up to. Remember, the mean is adding them all together. So we need to find the sum of fx, which will just be adding up this column here. For the mean, we'll need to divide that by the amount of numbers. Now the amount of numbers is shown with this frequency column here, so we need to add all those together. And then to find the mean, we just need to do the 34,500 divided by 210. The question asks us to give our answer to one decimal place, so our answer will be 164.3. The Venn diagram shows information about 30 books published in 2020. A is the event that the book was written by a British author. B is the event that the book was a bestseller, as in sold more than 100,000 copies. The numbers in the Venn diagram indicate the numbers of books. In the Venn diagram, explain what the number 10 means. The 10 is in the overlap of A and B. So it will be the number of books written by a British author and were a bestseller. Explain whether or not A and B are independent events by finding the probability of B and the probability of B given A. To find the probability of B, we're going to start by finding out how many of these books were in B. So we've got 10 and we've got 5, so that would be 15. And then we're going to put that over the total amount of books. Now we're told in the question there are 30 books. 15 over 30 is going to be the same as a half. To find the probability of B given A, we need to learn the formula, know the formula, that that's equal to the probability of A and B over the probability of A. Now, probability of A and B is just this middle number here, so it's going to be the 10 over the total amount, which is 30. The probability of A is the 10 and the 8, so that's going to be 18 over 30. There's a lot of fractions there, but the 30s here will just cancel each other out, so it's just going to be the same as 10 over 8, or that's going to be 5 over 9. So the probability of B given A is 5 over 9. The question asks whether A and B are independent events. So we'll need to write a conclusion to this, that A and B are not independent because the probability of B does not equal the probability of B given A, and they would need to be equal if A and B were independent. The map below shows the percentage change in domestic tourist visits across different regions of England and Wales between 2010 and 2011. Write down the percentage change in domestic tourist visits between 2010 and 2011 in Wales. Looking at our diagram, Wales is here, and you can see the shade here is this shade here. So we're looking at this answer here, which will be a 0 to 2% increase. There are 10 regions shown. Find the number of regions that the domestic tourist visits increased. Looking at our key, there is only one of these that show a decrease, and that's the white one. Looking at our map, there is only one region that is in white. Therefore, if there are 10 regions altogether and one that showed a decrease, then there will be 9 that increased. Bryant states that the domestic tourism in England and Wales increased overall between 2010 and 2011. Explain why this may not be the case. Looking at the map, every single region apart from Anglia increased, and Anglia was the only one that decreased. So chances are there was an increase overall, but we're not given the amounts. It could have been Anglia decreased by 10 million and all the other regions added together only increased by 1 million. We don't know the amounts. So our answer needs to say that we only know the percentages, not the amounts. State the statistical name for the type of map shown. A map that uses colour to show information is called a choropleth. It is estimated that 2% of a certain type of medical test gives a false positive result. The remaining tests provide accurate results. David took 2 such tests. He does not know if each test result is a false positive or accurate. Complete the probability tree diagram. Each of the false positives will be 0.02. So we can put that onto the tree diagram. And each probability have to add up to 1. So if the chance of a false positive is 0.02, take that away from 1 and you get 0.98. So each of the probabilities of an accurate result is 0.98. Find the probability that both of David's test results are accurate. With a tree diagram, we always start here. And if both of the tests are accurate, we're going to go down here, and then we're going to go down here. And all of the probabilities we collect along the way, what we're going to do is multiply them together. Because in probability, the word and it's accurate and accurate, means times. 0.98 times 0.98 is 0.9604. David states that the probability that exactly one of the tests is false positive is less than 4%. Find out whether or not David is correct. Looking at the tree diagram, if the first test is a false positive, the second would need to be accurate for us to have exactly one false positive. Looking along, it would be 0.02 times the 0.98, which will give us 0.0196. If the first test was accurate though, the second test would have to be a false positive to again give us that one false positive. But this is going to be 0.98 times 0.012 again. So this is also going to be 0.0196. Now with tree diagrams, if you've got 2 answers here and here, and you want to find the total probability, it's either going to be this one or this one. The word or means add. So what we're going to do is we're going to do 0.0196, add the other 0.0196, or just times it by 2. That will give us 0.0392. Now looking at what he is saying, he's saying that it's going to be less than 4%. So we need to convert this into a percentage. And we can do that by multiplying it by 100. So it will give us 3.92%, which is indeed less than 4%. And finally, we just need to write down what we found. So the probability of exactly one false positive is 3.92%. So David is correct because this is less than 4. Always make sure you say either that the person is correct or that they're wrong. The cumulative frequency step polygon shows information about the number of books borrowed from a local library over 70 days. Give a reason why a cumulative frequency step polygon has been used to display this data. A cumulative frequency step polygon is perfect for this situation because the number of books borrowed is discrete, meaning that you can't get 1.5 books. You either get 0, 1, 2, 3, etc. Find the mode of the number of books borrowed. You can find the mode on a cumulative frequency step polygon by looking at how much the line goes up. So it goes up a little bit here for 0, quite a lot here for 1, a tiny little bit here for 3, but by far the most it goes up is here for 4 books borrowed, and then a little bit for 6. So 4 is by far the most, so therefore 4 is the mode. Find the number of days where there were exactly 2 books borrowed, more than 2 books borrowed. If we look at the cumulative frequency step polygon for 2 books borrowed, notice that it doesn't go up at all. Therefore, for exactly 2 books borrowed, it's going to be 0. For more than 2 books borrowed, we can draw a line across from where we're currently at 2, and it's going to be all of these here. And so it goes up to 70, and we're at 25, so the distance here is going to be 70 take away 25, which is 45. So the more than 2 books borrowed is going to be 45. In 30 days, fewer than X books were borrowed. Find the value of X. We can draw a line across from 30, and we can see that all of the jumps up to the line are under 4. So our answer is going to be 4. Laura believes that the interquartile range of the number of books borrowed is 8. Explain why the interquartile range for this data cannot be 8. Looking at our cumulative frequency step polygon, the first time this graph goes up is at 0, and the last time it goes up is at 6. So the range will be 6 take away 0, which is 6. The interquartile range must be less than the range. So our answer is that the range is 6, so the interquartile range must be less than 6. You can complete a unique version of this paper by clicking the link. Our website is full of free content to help you with your exams. You can even save your scores with a free account. Enjoy!